Welcome to this Open Security Summit session. I want to give you a quick introduction to what we're doing and what to expect. So all sessions at the Open Security Summit are live streamed or recorded, and we share them for public use. And we publish them on the Open Security Summit YouTube channel, and we highly recommend you to go there and check out these amazing sessions that we already have there from the Cruz before. We want you to be involved, share with your network, and please, share the Zoom links that exist on the OSS website, which you can find here, and these allow you to log in straight away and see the sessions. We have an amazing content for this week, from CISO to cloud security to CDR to COVID to DevSecOps, and also a number of sessions on other topics which are super critical and important for us to address, including Wardley Maps, which is a big feature of the summit. And we go every day from 10:30 till 10 o'clock at night. And as you can see, there's something for everybody here. So please be involved, participate, and join us. And just a final comment on openness and respect. At the summit, everything we do is about openness. We share the information, but also we try to release everything that is created under Creative Commons and an open source license. And we expect you to participate, to have mutual respect, to have an objective distance on your comments, and to be very professional. And finally, we put a huge focus on respect. We have a diverse community. This is about respecting everybody's opinion, and we expect nobody to feel discriminated or not comfortable during the sessions. We also support heavily the Black Lives Matter current situation that happened worldwide, because we believe that is super important to reset how we address these important issues in our society. Finally, share your views. Here's the hashtag to use, and we have a Slack environment that you can join from the website homepage and enjoy and learn.
Great. And just a couple more little notes that I was asked to say. Use the chat functionality for any burning questions, and you can unmute ask directly. You can use the yes, no buttons and the thumb and down, thumbs up, thumbs down, or put the hand up if you want to do something. The host can be monitoring these windows, but it's always good sometimes if you nudge it. And this session, we're actually going to try to take some notes and some outcomes. We actually have a Google slide that we can use to do that. If you want to make changes, or if you want to start helping with that, please let us know. But we have a couple participants here that is going to help with that. And yep, and that's it. So I'm Dinis Cruz. I'm running a little bit of this session. We also have Simon Wardley, the creator of Wardley Maps, and we also have Adam, who actually is from the COVID Save Apps application and a developer, and he is going to basically providing us with good, basically real world experience of the application.
We also have Dermot McKenzie on from the app team as well, Dennis, to help me out with difficult questions.
Absolutely. Yeah, welcome. So this application here is actually, I think, is a really amazing synergy between what we're trying to do at the summit and what these guys are doing, and it's very relevant to in our world. We're all still in lockdown or quasi lockdown, and it's when we start the summit, I definitely was trying to ask the question: is there an open source COVID application? Surely there has to be one around the world, right? And I think there's a couple, but we engaged, and Adam was greatly amazingly responsive, and we did a bunch of sessions. We actually did some threat modeling. And I think it's really amazing for us to be able to help and for the security community to be involved, and especially because they already done a lot of paths on the way to committing to security. So let me just give you a quick introduction of kind of where we are, what we've done, and then the idea is to get into the kind of the mapping of this element and see where Wardley Maps can help with the next evolution, I would say, of the COVID Safe Paths app. So first of all, what it is, it's a mobile app. And Alan, this is where you absolutely have to correct me if I say anything wrong, or if I don't do a good representation of what you do. It's an app that basically saves the places you visit and stores them on the phone. So it's literally at the moment available on Android, on iPhone. It's not officially launched, right? It's on final beta, and it's about to go live in a number of places around the world. Cool. I know it's always amazing from a security point of view when there's a very strong commitment, and this is very important from a security because even if it's just required to pin the expectation and to have a way to act as a lever for a lot of decisions that happen later down the line. This is from their main website, and it's really powerful that they the public commitment here is the privacy first tools, right? And from a security, it's great because we can now, basically say, look, if you're talking the talk, you're going to have to walk the walk, which is great, right? Because there's a lot of applications that don't have this commitment. In fact, when we talk about labels and positioning and measuring later on, I actually think that this is one of the first checkboxes, right? Literally, are the apps positioning themselves as privacy first? And it's important, to in a way to be very focus here to understand that we want the most secure app to gain the most market share, right? That's the idea, right? The idea is that the apps that do the right thing from a security and privacy point of view should be the apps that end up being used around the world, because if not, there's going to be a ton of unintended side effects. So we actually start with 2 threat modeling sessions last 2 weeks ago, which went great. We got the videos so you can see online. And I think I like these videos because they're a good example of sometimes where the sausage factory of a threat model is, and then you can see the evolution, and you can see how the conversation evolved in there. They provided really amazing set of documentations, which I highly recommend to read. This is literally linked from the training session. So they provided documents about the privacy location, the safe places product definition, architectural, also about the user types, the API architecture, and the upload flows. And then from a security point of view, my view is always the more documentation you have, the better, right? There should be no black magic, no things go behind the scenes, right? No bits of code that you don't have access to. If you don't have access to the code, you don't have access to what's happening. Documentation, is very hard to then vouch for the security of something. We've tried to capture the data, on a GitHub repo. This is just a replication, a little bit of the data that's on the other side, but also allow us to maybe, innovate or put things that, consolidate a little bit. And but the idea is to collaborate with them as much as possible. So let's look at the threat model. So this is what we created during the session, and hopefully you can see my mouse. So I kind of will walk you through this. So in this situation, what happens? And this is sort of like the idea of threat models. When you look like this, you try to understand the trust boundaries. So what are the different types of trust boundary, different types of security requirements that we have here? But fundamentally, you have a mobile app who has some data that's been recorded, who submits that to a server. Then that person talks to a contact tracer that helps to clear up some of those things, like for example, the trips to what's the castle name? To the Durham Castle, right? And things that you're not supposed to be, and other stuff. Although in this case, I think there was a very wise man who said, we have to respect everybody's privacy, and the ones who says I don't have a problem because I have nothing to hide. I think it's like saying, well, I don't need speaking because I have nothing to say, right? So I don't want freedom of speech because I have nothing to say, right? That's not how it should work. So we need to protect everybody's privacy. We need to be very respectful of the data gets shared. And in this case, the data is again sent to an aggregate process. And this is very important because the data is then anonymized and then hashed and then sent to a global sort of repository, which is then pulled from the mobile app for the non-infected users that compares with that. So the idea is that if I know that I've now been in a place that another user has been, then I'm infected. And now there's a better view that I created from that, which is this one, which I kind of go a bit more detail because I think this introduces some of the key concepts. So from a data point of view, we kind of have 3 types of data here. We have anonymized. Actually, I forgot. I was going to add quotes. Sorry, because I think anonymized is still, the more I think about it, the more I actually think that there's tons of gaps around it. So I think we have anonymized as much as we can infection locations. These are locations that are known to have a person with COVID pass through it more than 5 minutes. I think that's the current timescale. We have filtered infection paths. And this is important because this is actually all the paths that the user gone through. And then we have the raw infection paths, which is the raw data before it's been filtered. Adam, is that kind of correct? The main key?
Yeah, I think that's broadly true.
Cool. So it all starts with the user, which is us, right? So each of us has the mobile safe path apps, and the app is saving locally the user location history. Mm-hmm. So, and from a security point of view, this is great because what we now start to see here is a whole number of security requirements. For example, a security requirement is that the location never leaves the mobile phone, right? And that's a key requirement, right? So anything that allows that location history to be shared even with other apps running on the same phone, then that's a vulnerability, which will then need to be fixed. Because that's a key requirement. So the Safe app downloads the AIL, which is anonymized infection locations, to the phone, which gets stored here, and is actually stored in a hashed way. So they actually store the hashes, and the idea is to make it a little bit hard, for the apps to calculate and so to create to create a full, almost like clear text version of the anonymized infection location. So you can see that the data gets hashed. So here we have one of the most important components of this, which is the creation of the anonymized infection location from the filtered infection paths, which is here. So this is the step where you take all the paths that the user grants, and then you create an anonymized view. We have a Node.js application that is then used, and this is important, by the mobile phone of the user. So the other part of the journey now becomes that you have a user that's been infected, he has a mobile app, he's using a React application, and basically this mobile app is going to send to the server the raw infection paths. And so the raw infection paths are stored on the server side in a database, right? At the moment they're using Google Cloud, but they might be using other things, right? And then there's also a React UI that exposes that. And this is now the other key part, is the tracer is going to use some computer, because they're going to be somewhere, to access the raw data. And is the tracer person that is actually going to help the filtering, and then is going to send the FIP, the filtered, through to the server, who then gets consolidated into AIL, who then gets sent to the user. Is that sounds about right?
Yeah, a couple of things I want to just clarify though, after having gone through it. I think when we're talking about filtered infection paths and raw infection paths, they are location points in time rather than paths an individual has taken between locations. Just it's a minor distinction. But it is quite important once you then try and anonymize that data.
So wait a minute with that, but if I have the timestamp, I can create the path, right?
You can, but what we're passing around and storing is solely those times and points in space, not any data around or linking the paths.
But if you tell me that I was here at 10:01 and there at 10:05 and there at 10:20, it's physically impossible for me not to have done that sequence of events, right? That you like, unless I'm doing hyper jumps, right? You know, like if you give me 20 points in a map, right? In fact, if you give me a map with 10 points, I can tell you exactly what paths the user went with a very high degree of certainty, right?
Agreed, but in terms of the data that's stored, it's solely those time-space points. You can infer the path from it if you've got a single user's data. Yeah.
I can even tell if the user's on foot, on bicycle, on car, right? I can
in
tell
the raw
that
data, once it's been filtered somewhat, once it's been filtered, so in the filtered stage, you can't necessarily, because you would draw a line on a graph, on a map, and because we may have removed waypoints as part of the filtering process, that's less true.
Yeah, this is where, for example, from a security point of view, we need to validate this, because I think you'll be surprised. I've seen exploits where, you know, like you do so much more with so much less data. Right? Mm-hmm. Like, look, if you get to the point where we can figure out your password just by hearing you type on your keyboard, right? And by doing mathematical calculations based on the speed of your typing. And if I actually have a little bit of the text that you're writing, I can get like really close to almost accurate prediction of what you're typing. You know, if you look at the complexity of that compared to this, you know, I think my point with this is like, it's important for us to understand the security, properties of that data, right? As we go there, right? Cool. Sorry. And any other comments?
Just one other thing, which is just to add to what you said, in terms of the unknown computer that the contact tracer is using, and the fact that we're using Google Cloud and for development. Just a reminder, and I know we covered this in the last session, we're building a piece of software that has a reference implementation that we're testing on, but there's a distinction between the infrastructure we're using now and what we'd expect the contact tracer to use. So we'd expect if the NHS, for instance, were to deploy this, it would not be unknown computer. They'd likely have some organizational constraints that would be an NHS managed computer. Similarly, if they were using Google Cloud, that would be because they had the relevant infrastructure in place to manage Google Cloud. So those things are a little bit out of scope in terms of what we're thinking about as an app team. But yes, they're relevant from a security perspective.
And I think the irony there is that I think a lot of organizations had a lot of control until everybody was working from home. And now the number of personal devices that have been used to access corporate environments is just like went off the charts. Simon or others, before we continue, any questions on the workflow and how the app is designed?
Not at the moment, though that doesn't mean I understand it yet.
Okay. And actually, I guess it might, so maybe this one might make it easy. So when I took it, I took this, and it was, what's very interesting about this, right, is I have a massive problem with graphs like this, right? Massive problem. Although it's nice when it looks nice. The biggest problem I have with this is that this is a work of art. In fact, you can already see that eventually I was trying to shove the trace person there, and then I have a problem with this, and then the arrows start to not work well, and it's a pain in the ass, right? Like literally, you start to fight the design of a graph, right? And it's wrong, because we should be able to mix and match. And then especially when you go into the thread models, the way I like to do it, where you create multiple versions of this, it would be insane, because you might spend more time doing a freaking diagram than actually doing analysis. So to make it kind of easy, simple, I transform it into this. So this is a graph, not a map, it's a graph, right? And what you have now is the needs from the top to the bottom, right? So what we have is we have a user, right? The user needs a mobile app, right? And the user needs AIP data. The AIP is anonymized infection locations. So that's what the user needs. If the user has those two things, the user can connect the dots and go like, oh, I've been infected. I need to do something about it. And actually, Adam, I had a question for you, right? Are you taking into account when the user captures his own test results?
So the user doesn't capture their coronavirus test results. That's what you mean. They don't capture that in the app. It is obviously inferred by the fact that they're talking to a contact tracer and want to.
No. That's not what I'm saying. I'm saying is that if a user tests negative, right? So let's say the user thinks it is, or just for some reason tests negative. Do you get that data?
So undiagnosed patients would generally not choose to share their data with a contact tracer because they haven't been diagnosed. Yeah, I think that's definitely an area worth exploring, because I think the data points that you get from it, including to feed the machine learning or the algorithms that you want to use to calculate stuff, I think that is a very valuable piece of information from the kind of false positives, false negatives element. Mm-hmm. So one way we're thinking about that is someone may they may later discover they've had an incorrect test, or they may share their data at a point they've been told to by the healthcare authority, but haven't had a positive result back yet.
Yeah.
So we are thinking about how does, from both a privacy and I guess integrity point of view, how does a user recall that data? So at the moment, they have to rely on verbal or email contact with the contact tracer, but the contact tracer does have the facility to revert a piece of data.
Cool. All right, cool. So what you see, so if you look from a user needs, right? The user needs two things, right? He needs a mobile app. He needs the AIP data. For that, you need a server, right? So we need a server that you can talk to, and the server needs to calculate the AIL, which needs to come from the FIP, which is the filtered infectious data, which needs a server. So there's probably a couple more lines that could go to the server here, but ultimately everything goes through a server. Then we need another app, another server, where we can store the raw data. This is the raw infection path that can be spoken to, used by a mobile app, which is the one that is used by the user. This is the one that is used by the user with COVID-19, and is the one that is used to store the raw infection paths. So this is the place where we have most amount of unfiltered, basically sensitive data, which exists within the user's mobile phone, which is kind of down here. And if you go, there's a second path to the client app that is used by the tracer agents, that he also needs to be able to filter the RIP, and he needs to actually be able to view the data there, right? So the tracer agent actually sees the RIP, right? And actually probably I was missing from here was the client, which is the computer that the person was using. Any questions?
Do you mind if I ask dumb?
Yes.
Oh, super duper. So, okay, this is actually easier for me to understand what's going on. So from the point of view of user general population, tell me when I'm getting this wrong. Basically, I have an application which receives infection location data. You've called it AIP. What's AIP? Did you mean AIL?
No, AIL, anonymized infection locations.
Good. It's just you called it AIP data at the top.
Sorry.
You meant AIL, right? So, no
AIL,
problem.
yes.
So I have an application on my phone, and I receive AIL data, which is basically saying, these are locations where people have been infected. That data comes from a server, which calculates the AIL, presumably on some basic knowledge about the paths that you are likely to take. Is that correct or not?
No. So it's everybody in the same region, for instance, would receive the same data.
Right, but it's by region. So, I mean, it's not the entire country. It is, say, by region in an area or whatever it happens to be. Yes? A city, town.
It's on the legal scope of the particular healthcare authority. So that would vary country to country, I guess.
Gotcha. Okay, perfect, super duper. All right, so it calculates pockets of AIL data, okay? And that data is based upon some store of you call it filtered infection paths. Yeah. So that is the known areas where people have been who've been infected. Is that correct?
So just to be clear here, the calculations regarding whether an individual has crossed a particular point of concern is done locally on the user's device.
Yes.
The calculation done on the server side is aggregation, deletion of old data, and hashing.
Okay. So the difference between what we call raw and filtered is raw contains everything that was captured on your mobile phone.
Yeah.
Filtered contains after a conversation with a tracer agent, or eventually the user saying, I don't want to share these particular locations, these particular paths that I did.
Oh, so the user actually can limit, control the paths they're actually sharing.
Yeah.
Okay. Right.
I know. And that usually hits on one of those balances between privacy, right, and quality of data. So if you want to respect the privacy of the individual, we have to let the individual define at least a bit of what that privacy is.
Okay. So what we're doing is therefore getting a subset of filtered paths.
Yes.
Rather than the whole lot. And that subset is based upon, if I'm meeting up with my local drug dealer or whatever happens to be, I want to switch those off. Is that correct?
Yeah, but I think it's...
I'm picking a deliberate example.
Of course, you're right. But from a privacy point of view, is we want to protect the vulnerable, right? We want to protect the ones who, have the most to lose by that data being manipulated in other ways, or the data being used against them.
Right. So if I'm meeting up with my offshore fund manager who's helping me squirrel millions away in my secret sort of offshore, do very criminal, nasty thing funds, I can make that conversation disappear.
Yeah. To just fill in a bit more, a kind of less extreme example. The guidelines we're offering to health authority, to the health departments that we work with, we advise that they remove all home address information. So they just draw a box around the user's home, so that they're not identifiable either by being in the home or being very near to that home. We recommend they remove all travel, particularly travel in vehicles and cars where they were unlikely to infect anybody anyway.
Yeah.
And we recommend they remove any personal visits they've made to kind of frankly friends' houses. So what's really going to be left is the public places that they've been and the durations of time that they're in those public places.
Gotcha. Okay, that makes perfect sense. Thank you very much. Okay, good.
Unless they were meeting the drug dealer at the public place, in which case,
But Simon,
yeah.
there's a presentation that you delivered where you talk about this correlation between planes going to the same place, and once you have enough data, you can actually track them back. I think you can still track back those drug dealers.
No. You can do an awful lot. So just for just because that people may not be aware of that story, back in 2008, what I used to do was track the movement of private jets across the United States, because you could all these companies spent all their time securing data and everything else, and then execs would jump on private jets and go and fly to go meet with other execs at often remote locations. And that told you that one company A was talking to one company B, and that was great for mergers and acquisitions. So prior to an acquisition, you'd get all these execs, super secret, jump in a jet, leak like a sieve. And so you'd know that this company was about to buy that company. So great fun. All right. So, but now I understand. So it's the health authority can limit and filter certain sources of information and the individual as well. Is that correct?
So technically, the filtering in the current implementation, the filtering is performed by the health department. They're the people who have the technology to do it.
Okay,
but
gotcha.
they're doing so in collaboration with the user. And part of the flow is before they effectively hit to officially, I guess, designate the data as FIP in this model. There's an explicit consent conversation with the user. Says, you're happy that we, everything we've been through. You're happy for this now to become effectively to go into our data set.
Okay, super duper. And that data which is being fed into it, I mean, that's from, these are anonymized infection locations, so paths. So these are basically regardless of whether somebody's infected or not. So there's going to be an awful lot of discussion, certainly in the setup with users. Is that correct?
So the person who's having the conversation here is somebody who has been diagnosed with COVID.
Okay.
And the RIP data, this is the raw data is basically a log every 5 minutes on their phone for the 2 weeks prior to this conversation.
Perfect. Okay.
Possibly removed by any times they chose to turn location logging off on their phone.
Gotcha.
Which they may have done. So it's a set of up to 4,000 data points, one every 5 minutes from this infected user. As input to that conversation about what of that data do they want to publish.
Right. So just to recap for me, general user, general population has an application which downloads on it anonymized infection locations, which compares their existing journeys on the phone compared to that data. That data, which is centrally stored, comes from a filtered list of infection paths. Those filtered list of infection paths comes from the raw infection data of people who have been diagnosed as infected and their pathways, which is then filtered through the health authority with some discussion with the people who are victims of COVID to create a filtered list, and that filtered list is what is then used in the different regions to provide the AIL data. Is that correct, roughly?
Yeah, that's about right.
I think so.
Right, perfect. Right, thank you. I understand it now. I find this a lot easier to understand the previous diagram, by the way. I don't know why.
Well, because it is easy to understand. Which is why usually when you do have this, which by the way, this is the kind of stuff that, when I do threat models, I ask, do you have one of these? And the real world will be bigger than this. but then usually we already had a date. So we go to the whiteboard and draw one of these.
Okay.
Because it's kind of like.
So the previous diagram you had, if you just flip back.
Yeah.
I find it pretty, but confusing. And it's difficult for me to really understand where the user need is coming from. Whereas this one, the next one, it's better. I find it easier for some reason. It's more along the path. Maybe because it uses general population, what is my need? I want to know if I've been in an area which somebody's been infected, has been into. That's the need. And that comes across more clearly for me. Anyway, sorry. I'll shut up at that point.
No, you're spot on. So the problem is that it's not a map. It's like, if I do this, right, which is the same graph, the same connections, the same nodes, I just swapped this guy to the other side. You can see the user still has, so that should be AI, should be AIL, not AIP, sorry. But this from a graph point of view, they're the same, right? The same amount of nodes, same amount of connections.
Identical, yeah.
Identical, right? But that's why they're graphs and not a map, right? So I could do the same thing with this guy, right? I could move it around, I could play around, or even this one here, right? I can move it around, I can make it more pretty, right? But it's still, the position wouldn't matter, which also means that, what we need is a map. Because if we want to talk about which one to protect, where to use cryptography, which ones to outsource, which ones to actually, where's our strategy, where's our movement? And there's a very interesting situation that occurred through the threat modeling, which I want to start there, which I think was quite interesting from a crypto point of view, right? So what we really want is this, right? So now what we have is a first pass where immediately you get to see my bias, you get to see my initial thinking on a lot of these, and now we can challenge it, right? So if you look at from the Wardley maps, so actually, I guess it's probably, and I guess who better than you, Simon? So I'll ask you to do this. Can you explain this map to Adam? Because I'm not sure they have seen it before. So you can explain the structure, and then I can explain the content if you want. Oh, I think we lost you, Simon. Was it me?
Hello. Sorry.
Hello.
No, that's my fault for not putting on the speaker. Sorry, I'm just fiddling around at the same time here. I just want to check something. Excellent news! I can draw on your screen. Can you see me drawing?
Yeah.
Right. Super duper. So the first thing with a map, I'm just going to say is where it says visible value chain invisible over here. Just ignore that. That's all training wheels. And really what we're talking about is a chain of needs, each of which contain components of capital, which are evolving through a common pattern. So it doesn't matter whether we're talking about practices or physical activities. We start with the genesis, which is totally novel, new. No one's ever done this before. Custom built examples, exists in places. It's pretty rare. We're getting better understanding. Products, good practices, that sort of thing exists over here. And right on the right-hand side is where the stuff is commodity, etc. Should definitely be outsourced if you can outsource it. It's like if you're building an application, somewhere down the bottom is power. The last thing you want to do is start building a power station because you want to build an application. No, you don't want to do any of that nonsense. So we start with the point of references at the top. Now, one of the things about the maps is you can challenge map. So I can challenge a map in a way I can't challenge a story, because if you gave me this as a story and I challenge it, I'm actually challenging you as the storyteller. With a map, I can say this map is, I disagree with the map without making it personal to you, hopefully. So the first thing, you've got users here. I'm going to say immediately, there's another user, which is the, I've already heard, which is the health, provider. Okay, sorry, my handwriting terrible with one of these pens. So the user has certain needs. I would imagine the health provider has other needs as well. And hopefully these will overlap together. So I would tend to actually start the map from that point of view. But taking the focus of the user, I want to know, where if I go somewhere, am I safe or not? So you've got two parts. One part is some sort of custom built application, a mobile application, Safe Places app. Well, it's certainly true that there are not products out there that I'm aware of which do this sort of contract tracing. Most of them are custom built examples. And then you've got the AIP data. Now you've put the AIP data in product. I am assuming, in this case, you actually mean AIL data.
AIL, yes.
Yeah. That sort of infected pathway type data. Again, there's no product you can buy or anything else. I would imagine that's more over on this end as well, but that's okay. What we're saying is,
but that's a good example of the challenge, right? So in fact, when I started, I actually on the other side, but then my thinking on this one, and then, so Adam, like the power of a maps is we can have this conversation, right? Is that we have, for example, a lot of experience in creating anonymized data. So for example, the NHS does that all the time. So the concept of creating anonymized data is quite mature, right? Okay. And we kind of, where, it's like maybe 10 years ago, the first time that, we were trying to release data to the public where we made tons of mistakes, maybe that was on the other side. So that was the thinking there.
Okay, so what you've got is you've got one node, which is infection data.
Yeah.
Okay. And then you've got basically anonymized.
Yeah.
Okay, and whereas this anonymized might be in the more commodity, the infection data is more in the product. So, sorry, just slightly rotate that by 35 degrees so it's flattened, which is what you're talking about. Okay, so of course the issue, there's several issues here. Is one, you're doing an open source pathway, and really that you want to, ideally, both the anonymized data and the application needs to be widespread, well-defined, not proprietary everywhere. It needs to be driven over into this commodity section. But I'm getting ahead of myself. So we're talking about Safe Places application data, and there's Safe Places application server. So really, the server stuff here, all it is it's a server delivering a set of data. So through some basic web service. So really, that to me, despite being given a fancy name, sounds like it should be over here more. There's nothing special about it. The thing that makes this different is the data set being provided. Is that correct?
Yeah, but on this case, the server app is still being developed, so it's still on the custom build stage.
But in terms of the novelty of what it's trying to do, in that context, it's quite low. If you look at where the equivalent server is supporting the UI that supports contact tracers and doing what they're doing, that's much more novel from a functional perspective, but isn't really novel from a technology perspective.
Okay. But in terms of all we're talking about is, I don't know, what are they called, Bloom filters or whatever? I don't know quite the way in which you're doing it, but
it's a Node.js application that helps. It's
I think the bit that's been circled in red is not, though. Once with the AOL data has been calculated, it's just a flat text file that's downloaded from a from a totally standard web server.
Okay, so this right. For me, I mean that's just over here. So mobile devices totally agree over here, commodity. This is commodity. I mean, the reason why I emphasize, I just try and push things to where they are, is otherwise, you'll get the consultancies coming in and trying to charge huge amounts of fortune for building basically what is just a basic web server providing file. Sorry. Right. So the calculation of the AIL. So this is basically taking what is the filtered pathways and breaking it down into region. Yes.
Yes.
I'm asking. Is that correct? Yes.
So if we look at what it's depending upon, which is the filtered data, what this is actually doing is aggregating, archiving old data and hashing.
Okay. But again, none of these sorts of things, nothing special. That doesn't sound okay. Fine. And this is a store, nothing special about that. So hopefully S3 buckets, EC2, great. That's a store for that. So S3 buckets or whatever. Safe Places app server. So hang on a second. So this application here is the bit where actually a tracer is interacting with an application, identifying, that stuff which is taking it from raw to filtered. Is that correct?
Yes, this is actually two separate physical implementations. There's a set of services which feed the mobile and a set of services which feed the web clients. Okay,
but this is the mobile of people who've actually been affected. So these are, COVID-19 patients, yeah? So it's a different application. How do they get that application, by the way? Is it when they get infected, they get contacted by somebody and told to download the application? Or is the application fundamentally the same as the application up here?
Ideally, that's the same application as an undiagnosed user would install. So ideally, they've been alerted through a government PR campaign or something to install it in advance.
Okay, so if you're a COVID-19 patient, you've got exactly the same application as the one up here, but some mechanism of identifying your data as being, because in the case of the public person walking around, they download data, which is on the infected paths, and their local machine, their mobile, looks at their paths and whether they've gone into those infected paths. But in the case of somebody who's been infected, they must be providing their raw paths as well. So there must be a difference in the application, because in one is downloading and the other is not only downloading but transmitting.
There's a difference in the flow you would follow in the application. So to bring that to life a bit, there's one person who's a contact tracer who's sat using the web application, and there's one person who's a recently diagnosed user who has had the mobile app installed for, say, 2 weeks. So when there's that conversation that's going on between the contact tracer and the newly diagnosed person, the contact tracer will say, okay, so you've been diagnosed, so I want you to navigate through this flow in the app to export your location data. There's a series of consent screens, and then the web app displays a 6-digit code. And then the person with the mobile app enters that 6-digit code, and the consent is, the consent payload includes that code, and then the uploaded data includes that code.
Right. Okay,
there isn't a, you are John Smith and you are infected and we know you are. It's solely, you both have this 6-digit code at the same moment in time and are on the phone.
So, yes, I understand. And I just want to double check, though, that when it comes to, one is receiving and one is transmitting. So there's the receiving of the AIL data, and then there's transmitting of your data when you're somebody who's infected. That transmission, which, you know, is associated with that 6-digit code rather than being associated with a person, when that transmission is activated by the individual themselves, yes? It's not a case of all data is transmitted. That individual has to go into the application and say transmit. And if I'm an individual who's not infected, can I go into the application and go transmit my data anyway?
Yes, and the data will not be picked up by the system because it will be treated as an unauthenticated person who hasn't got a 6-digit code trying to spam the system.
So in practice, you can. So the flow there is that you have to speak to a contact tracer person that will validate the fact that, yes, you have been diagnosed, yes, you've been infected. And there's a tracer that starts the process. So yeah, actually from a security point of view, you can't upload because you don't have the code to upload.
Now, I understand. So from the point of view, there's users, general population, there's non-affected. Sorry, this is not going to be in the right position. But, and there is users who've basically got COVID. Okay.
Yeah, which is actually the one at the bottom left. If you look at Genesis, user with COVID-19, that's the one.
Yeah, so they're both using exactly the same app. But one path is about basically receiving, and then there's another path which is about transmission.
Yes.
And sorry, I'm messing up your map badly. Just to draw the lines, you'd have to put, and that in that transmission, okay, there is also some element of authentication. And so there's some sort of element of authentication, which is where we've got the link over to the health provider. Because the health provider is the, authentication or to the tracer agents, I should say. So there is a link between the tracer agents and authentication for the transmission. And there's also a link, and I presume there's a link between the health provider and the tracer agents. There's a link from the health providers to the actual the conversion down here. So I would reorganize personally. So this is one of the terrible things that happen with Matt. I would reorganize it and starting at the top. I have users who are non-infected, users who are infected, but I've also got the healthcare provider as well, because there's two things in terms of defining what is the data that goes from what did you call it? RIP to FIP, the FIP to the AIL. The health provider is involved in that process, but also through the tracer agents, they're also involved in the authentication of the transmission data, because both users can transmit data. It's just one group, it gets accepted, one group it doesn't. Is that correct?
Yes, that's right.
So this the other thing I like about maps is that it doesn't matter whether I'm doing reducing global poverty with the UN or whatever it is I find them very rapid for me supposedly getting an understanding of a space. It may be very faulty, but anyway. So let me just keep on going. Sorry. So I've got this bit here, and hang on. No, sorry. Ignore that. What we've got is, put a green because I'm making it all a mess with red. So this here is the same as this here. It's just the difference is just in terms of authentication of transmission. So safe client app. Okay. So this is the bit where basically the tracers, in discussion with whoever is infected, is determining, what is going from the raw infection to the. So the user basically says, I've got COVID, I've got the code, I've uploaded my data. Then there's a discussion going on between the tracer agent about which bits they're willing to share in order to help other people. Is that correct? Yeah, good. And so they can then, they can both view the RP and the filter, right? Okay. And again, so in terms of tracer agents, I mean, really, a lot of this stuff I would shift over a little bit, but in terms of just filtering our RIP into FID, that's just basically saying, this set of data, there's nothing special about that. It's just except for the fact that you've got to create some interface. So the action itself is nothing special. It's just this path is accepted, this path isn't. It's just creating an interface to do that, which is why you've got all of this in custom built. The one place I would look is people like RNLI and the police themselves, only because they have the same problem, or a similar type problem, if they've got incidents and they've got to get resources. Sorry, this is not a map. Just draw a little box. You've got incidents and you've got people and you've got resources, and they need to get them to the same sort of place. It's the same sort of, is it the same problem? No, it's not. Forget what I was saying. Just ignore me. Sometimes I talk gibberish.
If they're willing to donate their code though, we'd happily have a look at it.
Yeah, no, it's just purely, it's the visualization of multiple different pathways. What you're talking about is a tool to basically very quickly for a tracer, because they're going to see all these different paths for this person, is how do you filter out? Now, the obvious ones are like, where's your home? Fair enough, etc., etc. If you're going to give them any freedom in terms of, I don't want to share this data or that data or whatever, is that actually done on the user side, and that's done in contact with the tracer themselves?
At the moment, it's done by the tracer. So they're using kind of a Google Maps style UI, if you can imagine Google Maps plotting
Yeah.
where you'd be in today, that sort of thing, but with the functionality to right click and remove or select a bunch of points and remove. The goal is to move that red action into the user's hands. So rather than telling the contact tracer you went to Barnard Castle and you don't want it to be public, you can do that in some kind of rich UI on your phone, but that's not ready yet.
Okay, so basically the app itself anyway has components in it, which basically are highly commodity. So that's like the Google Maps and all the rest of it. And so it's a bit like the rural payment agency, here's a map of some countryside or whatever, and here's your farm, and you had to draw your farm in Google Apps, that sort of thing. The difference being is here's your paths on Google Maps. You need to go through the process of deleting the ones you don't want shown. And at the moment that's done by the tracer, and eventually this you're hoping to be done by, and I presume that's a functionality you can give to every user, because ultimately every user should be able to see what data is being collected. If they want to delete data on their phone, they can delete data on their phone if they wish to, and only if they wish to transmit it they can do. It's just it will mostly be ignored except for those who've been authenticated. Would that be correct?
Yes.
Okay, good. Because you may as well provide exactly the same functionality. I mean, the fact that I'm not infected or whatever, and I want to go and delete a trip, which actually meant I was going to go into an infected area, and it would have alerted me if I didn't want to keep that trip secret. Surely that's my choice. It's daft, but
Well, I think this is where I feel the balance of privacy and I my kind of view on this is that we have to be careful a little bit with the expectation of privacy, because I like the definition of privacy that it is almost what you expect it to be. So you lose privacy when you are surprised, which is why again we've been eroded nicely by a lot of the current players, right? We know what they're doing, but the point is that I think we have to be careful on how much privacy almost like you do at this level, because I feel that the real sweet spot is to calculate AIL one in the middle.
Okay.
So from a security point of view, my expectation is that private data from the user will leak. So
Okay.
most users will leak data that they will probably consider private that will pass through that filter.
Okay.
So, yeah.
Giving the people, ideally you want the application to work, to make the application as simple as possible. You want to work it to work in exactly the same way, regardless if somebody's is infected or not. The only difference being is that you want to authenticate that data set coming from infected people to produce ultimately to produce the AIL, and the rest of it you probably want to discard, or because data is so cheap, you might want to keep it, but it may have some other use later on. But from the point of view of the user should get to decide what paths, and of course, if they start removing paths, if they're infected, that means the AIL is less of a lesser quality. And if they are not infected and they delete their paths from the system, that means, they're going to get less information if in fact they walked through an area where there was somebody who was infected, or they were in an area. But that's okay. I mean, you're not talking about the perfect all singing and all dancing and covers every single case.
Yeah.
And at the end of the day, all we want to do is bring the R number significantly below a 1. So if it catches most cases, that's brilliant. I mean, it doesn't, it's not going to catch every single case that happens to be, because you've got the other issue that only 80% of people have a mobile phone anyway. So you're missing 20% of the data set before you've got started.
And remember that the model, right, of the centralized app is you see that view RIP, so so the user's RIP there, which is the raw infection paths, that is literally sent to the server. That's the centralized model. Right? The centralized model is that from a privacy point of view, all that data is out of the user's hands straight away.
So this raw infection path data here that you've got is basically what I'm saying. This is what's being transmitted, and it should come from any user, regardless of whether they're infected or not. It's up to them if they wish to transmit. The distinction being is that you've already, with the traces, identified that data which you've got an interest in. If other people want to transmit their data, fine. I mean, just because they're not infected today doesn't mean we don't discover they're not infected actually a week later. So it'd be useful to have
the current model doesn't support that, but I actually think it's something that they probably need to consider, because that's definitely an extension of the system. Once the system is in place, the temptation is there will be temptation to do that, right? And one of the maps I want to create is a map that, you know, on the axis, you're actually tracking privacy, and you're tracking, you know, how privacy aware some of these components are. Yeah. And the logic of this is to make sure that we have the least amount of data being exposed as possible.
So one thing this exercise is particularly telling me is it would be really useful if I could just move these components anyway and write on them without, because my scribble is pretty unreadable. Did any of that make sense to people? Shall I just wipe this all out now, or did that make sense to people?
No, it was good.
So I got to summarize, most of the components, I would argue, you know, are more commodity. Things like this is just there's a web server providing a, you know, just a file for you to upload. The stuff down here in terms of the client application, this, as you said, this is just a demonstration of pathways, which, you know, somebody gets to decide whether or not, you know, it's in or not. And I'm going to say that with a limited number of traces and a large number of people, it'd be so much better if the users can get to decide what data they're willing to share. So really that most of that should be up here. In terms of sharing the data, everybody should be able to press the transmit button if they wish to share their data. But what's needed by, I imagine, from the trace and healthcare is the authentication mechanism. So there needs to be a way of somebody, you know, everybody transmits, everybody gets a code, they store their data, they're sharing, they're trying to help, blah, blah, blah. If they've got COVID, they need a way of authenticating with a tracer that their data is actually infected data. And so it can be pulled out of the general store and used to actually trace these filtered paths. And most of these components, I would say, more on the right-hand side.
But Adam, correct me if I'm wrong, the idea of this app is to actually prevent some of that from happening, right? You want to prevent, you know, mass uploads of data, because you want to, the core design is that data always stays on the user, correct?
That's right. So if the user tries to send their data from the mobile app with an invalid access code, it will get thrown back by the web services layer and not stored. I guess, like, in terms of the scenario where someone didn't have the app installed and then they learned they were infected, we are looking at some functionality to import previous location history if, say, they've got Google location history turned on. In terms of the scenario where someone wants to send data and they haven't been told to by a healthcare authority, that's just not something we support at the moment.
Yeah. So
is there a reason for that? Are we talking about because of the volume of data? Because, you know, big data occurs because data is so damn cheap to store.
No, it's privacy. Can I draw on that?
Yeah.
You can wipe it all out and draw on it whatever way you wish.
Can we wipe it? Okay.
Yeah. Let me.
All right, cool. All right, yeah, got it. Sorry. So and I do apologize for wiping your my
drawing. Scribble. Don't worry.
So yeah. So basically, the logic here, right, of this, and this is actually where the other what's it called? The other diagram at the moment is probably a little bit easier. The logic here, if you look at this, is to keep. If you look at it from a trust boundary, so that's one of the things I want to do, but I didn't do. What I was going to do to the maps is this is a trust boundary of the user data. Actually, maybe there. Sorry, at the top. So the idea is that the data never leaves here. So that's kind of the privacy commitment to the user.
Well, that's a lie. That is a lie.
No. Okay. It doesn't leave until you are diagnosed.
Okay.
The commitment we make is that the data never leaves your phone without your consent. That's the wording that we use.
So that's the difference. Okay, it leaves within your consent. To say the data doesn't leave your phone is a lie. It does.
Yes.
With your consent.
And when you are infected.
We only agree, from the sounds of things, to consent to you sending your data if we know you're infected.
But the pattern that you're describing is a centralized tracing model.
Okay, so I have to say that diagram doesn't make sense to me. Go back to the map.
So the model you're describing, right, is if you look at here, okay, so that's IIL. Right. The logic is that the data stays here because until you are infected, right?
All right, jump to the next slide. Right, no, the map one. Right, okay. So what you've got, the user, and by the user we mean, in this case, infected and non-infected, have an application which data is uploaded to them, okay? But, we go back to the transmission line, which is not there, which is sort of shown down the bottom. It should be at the top. We can transmit, okay, our data as long as we've been authenticated to, and that requires the traces at the top. And so that is the consent. The consent is, I agree, and I get a code from the traces, and I enter the code by the traces. That doesn't mean that the application can't transmit data. It always can do, as long as we have consent, okay? Otherwise, if I try and transmit, it's just going to get rejected, which is what we heard earlier as well, because I, with the application, can send my data, but if I haven't got a code, it's going to be rejected. Is that correct?
Yes. And now can I draw? Okay, cool.
Yes.
The problem that we can then have is that if we move to that model, then this becomes a massive thing, which is, can I move it? Can I move it? Oh, cool. So authorization, I can't move it, sorry, but auth, right? Which is the authentication and authorization of users, becomes a massive problem. So what I like about this solution is actually, from a security model, it actually puts a number of restraints into the system that actually make it safer.
No, hang on. So I'm not understanding something then, because you're talking about transmission as this being a different model, okay? And my understanding, as we stand at the moment, okay, is you've got the same app, regardless of whether you're infected or not. Whether you're infected or not, you can transmit your data, but the point is your data will be rejected by the server over here, where it's collected, unless you've been authenticated, got an authentication code. Okay, so if you don't have the 6-digit code, you can transmit your data and it's just going to get rejected. Is that roughly right?
Mm-hmm.
Hello, Adam?
It is,
Sorry.
yes.
It is. So this model is already in place, Denise. It's not, you're talking down here as what you like the model, but the problem with authentication. This authentication already exists. You're already doing this.
No, but what they're not doing is the mass upload of data or the upload of data when you're not infected.
No, so so you're basically rejecting data from people who aren't authenticated, and so it's consent, as in I consent to send my data, but it's also authentication as well.
Yeah, and actually, what's very interesting?
Hang on, can we just check, Adam? Is that right?
Yes, but just to be clear, the phone isn't sending the data regularly.
Okay.
The user needs to select get a specific flow that talks about privacy. They see the Healthcare Authority's privacy policy, and then they consent, and then they input the 6-digit access code, and that's a one-off transfer. So whilst it's true to say we can accept data from people that haven't been infected with coronavirus, it'd be quite difficult for that to actually happen.
Okay, so you are okay, but you'd reject it anyway because they haven't got the 6-digit code.
Exactly.
Yeah. Okay, good. All right. But it also means in future, if they wanted to transmit, you could build a process whereby, because you're authenticating the users anyway, as in giving them the 6-digit code, there will be a way of, hey, you know, in the future, you might want to do it that anybody can submit their data. Here, create your 6-digit code. But some people, you know, you'll submit the data with the tracers, and the tracers will mark off the 6-digit code as being that's an infected person. And that way, if somebody becomes infected at a later stage, you can just note that the 6-digit or whatever identifier you're using, that is now an infected person. That's fine.
So Adam, what Simon is doing, which is actually a worry that I have, and especially when you guys talk about reference implementation and deployed versions, is how easy it would be to transform this app and this workflow into a centralized tracing model. Because once you got these components in place, and actually there's a very great map that we need to do, which is this solution is actually introducing attrition on purpose. So one of the things that we haven't talked about in Wardley Maps is there's a concept of attrition, is when you prevent things from moving from one state to the other. Right. So what this app is actually doing is, by design, is introducing a level of attrition by only allowing certain types of data to come in. But I think it's very important that one of the risks that you have in place is the ability to change this app to become a centralized tracing app. And it could be something as simple as the traces are not scaling. You know, we can't get those in. Let's get the data in, because at least we do something about it, and you back into the centralized model.
Yes, we've got no protection against that, right? Neither does any other open source project. I'm sure the Linux kernels are used for bad things that their authors didn't anticipate they would be used for. What can we do about it? I mean, we can try and control it as much from a brand and a healthcare authority management point of view as we can with technical controls. But as we talked about last time, those can be bypassed easily by a nation state manipulating DNS or something like that. We can also we can build more and more privacy preserving functionality into the application, so that the cost of stripping it out begins to put off people who want to do bad things, and they instead focus on building their own teapot's empty, building their own solution. But how much effort we put into doing these things, given the non-novelty of a lot of these components, is the debate, I think.
Yeah, and also we need to take into account that, you know, there's already a lot of deployments out there who are doing this without any of these concerns, right? So the reality is that I think this app has the potential to gain mass usage because it doesn't have that data. So it's an interesting case where the fact that you remove a certain capabilities from the app, I think make it more wide and population appeal, and actually prevent it from being abused in the ways that other apps will do, which then will lose customer. In fact, one of the things that we should have here is mapping the user's trust on the app, which is very significant in this case, right? And sometimes the user's trust can be forced because, you know, you can get mandated to use, but in a lot of these apps, there's almost a requirement for us to trust that the app is actually doing what it says it's supposed to be doing, not anything else. And the data is, sorry,
no, I didn't mean to interrupt, apologies. So from that point of view, if I talk about a user and I have one need, which is, you know, I want to know, you know, what is my risk? Have I been exposed or whatever? But on another side, you know, I want the concerns about privacy. And what I like particularly about the app and the way that you talked about it is this was consent. I spelled consent right there, wrong consent. Right. So basically giving the ability for anybody to transmit their data. You don't want to try and prevent people transmitting their data. Well, I'd say the key thing is what you want is people consenting. So, you know, I'm not infected now, but I might be in the future. Is it okay to transmit my data? It's up to me, yes or no. Or, you know, I make it an active step. I am infected, so I want to transmit my data to prevent harm to others. But then the next step is the data that I'm going to transmit. Here are my paths. Is there anything I want to remove? I want to remove where my home is and all the rest of it. So I'm involved in that process. And if I choose not to send my data, if I'm infected and I'm not giving you my data, fine. Because at the end of the day, we're only going to get a percentage of the population anyway, and we're just trying to improve that. So you've already got it covered with the concept of consent. So the one thing you don't want to avoid is, of course, that data on the server side being captured and misused and all the rest of it. And that's just the generic sort of security mechanisms that you can put in place. But the other thing you want to do is you need to do the authentication. The authentication in this bit authentication is the wrong word. This is the bit where you're basically saying this person's data, this is an infected person. Now, of course, that is a privacy, and that's why having the phone call, having it on the server side. And so what you're doing there is just the identify off the total data set of pathways, what is the raw infected pathways. So now you say, well, the danger is that people may misuse this in different ways to look at where people are going. Okay, they might do, but this is a consent-based model. It's up to people to share
but there's another threat agent that you're not considering, which is the submission of bad data. So one of the use cases that they actually covered on one of the documents they published was to protect business. So one of the problems you have here is that if you can submit bad data, you can game the data sets, right? So you can make some, for example, if I have a competitor, I have vested interest in my competitor's restaurant to be shut down because of COVID.
But
right?
you've got two steps. You've got the transmission and the authentication step. As in, anybody can transmit. This is consent. But you've got the tracers doing the authentication bit, which is the bit that protects against that mechanism. Is this a genuinely infected person? Is that what you're saying?
Well, yeah, but you can't. If you as soon as you start sending data, you have to control the quality of the data that you have. So at the moment, the tracer actually is a limiting factor, but is a quality control. The tracer and in this model make sure that the data that you have that enters the system has a decent level of quality.
Yeah, and I'm not saying take that away. All I'm saying is that, in fact, you've got the same process regardless of whether somebody's infected or not, in the fact that you've got transmission, which is consent. Because I assume that if somebody has got COVID, the app doesn't force the transmission of data. In the same way that if you haven't got COVID, you could decide to transmit your data. But the question of whether it is ignored or used or not is that question of the authority with the tracers in terms of this 6-digit code is data which we're going to use in the raw infected path, whereas this data is not. Am I making sense, or am I confusing?
Yeah, no, that's all correct.
Okay, so you've already got it covered in terms of consent and transmission and authority in terms of the tracers. You could use this to allow everybody to submit their data. And that's just purely a question of the economic cost of storing that data. And then it comes down to, it has advantages that if somebody later becomes infected, they've already provided some of their pathways. So that data may be useful.
But on that one is the economic cost of authenticating the user, not storing. Is the authentication that is the hard part.
Okay, I think the key cost is the cost of redaction. So the moment model is that we do not store on a long-term basis any we've called it filtered in this model, any non-filtered data. And the filtering is a manual process, which would take significant time. That's something we could outsource to the user, as we've discussed, but we haven't currently.
Okay, so agreed in terms of the Google but graph path thing is something which you can put to the user, but the filtering, the filtering, you're authenticating on the 6-digit code, and that's an automated process.
So yes, the authentication, the filtering is, so we call it redaction. The redaction process, that's scrubbing out the points for the home, scrubbing out the points for travel. That's a manual process at the moment.
Yes, but you'd only do those for the infected users.
Well, sure. On the basis that we're discarding the non-infected data, that's fine.
Yes.
If we were to store the non-infected data, that would become problematic, because I don't think we want to be storing on a long-term basis the unredacted data.
Ah, okay, I see what you mean.
Because
Okay,
it's
good point.
an additional asset that we don't need, and I don't really want to keep it because it's just a potential target.
Okay, no, that's a really good point. And of course, if the pressure, if the users were the ones who were deciding on the path, then it's purely their consent in terms of what data they're providing, whether they're infected or not. Would that cause you a problem as well?
So they self-redact, so they self-filter the data and then they submit the filtered data.
Yeah.
Well, this is where in various previous conversations we've got, we've talked about the various values of various bits of data and so on. I mean, one of our Adam might be able to talk to this. One of our sort of privacy principles on the project is that we don't store any data for which we don't have a specific purpose.
Yep.
And we don't store it for any longer than necessary.
Right.
And that sounds to me like storing data for which we don't have any specific purpose on the basis that, hey, it might be useful one day, which is something we've, I know a lot of people do that, but it's something we're specifically saying we don't want to do as part of our privacy principles.
Yeah.
Okay, fair enough. So in which case you're doing it transmission, consent, authentication, and all the data which isn't authenticated with the tracer is being thrown away. All right.
Yeah, which is actually a core design principle from a privacy point of view. Because if we were designing this without privacy content, without privacy concerns, we would do exactly what you're describing. Right? We would store everything. We would find a way to fingerprint the user. We would find a way to connect the user to his identity. We would absolutely track the users, and we'd create what some companies and some organizations have created, is a gigantic tracing machine for the population. Right?
Yeah, I know it. And this is all going to be open source, yeah?
Oh, it's already open source,
Yeah.
So there's a question here where somebody, I think it was Martin, and you guys were on the chat, is about the scribble. So this is actually was a bit my fault, because I actually created this again as a piece of art, because I actually created this. I think I created this on Lucid Charts. What we should have been using is actually, I'll just quickly share this. We should have been using something a bit more commoditized, because we should have been using something like this, which is the online, online Wardley maps. You can come in here, and then you can create a programmatic version of this, and that way you can actually move around. You can actually change things. So you can see that we can come in here. If we don't like water, we can change that to AAA, and then we apply that to here, right? So you can see this, and he also shows evolution. So that would be a better way of doing this in a more scalable way. So apologize. I was gonna try to create it here. I just ran out of time. But if we have done it here, we would be able to run the multiple variations of the system. So let me go back to screen. So one of the topics I wanted to cover, which is one of the areas where I think we spoke last time from a security point of view. Oh, no, sorry, wrong map. That's the one for 10 o'clock. Oops, sorry. That's the 10 o'clock one. Where's the, here we go. So one of the areas I wanted to talk about here was where some of the assets are. So you can see that from a privacy point of view, the least amount of assets that you have, the better, right? Because the least amount of assets that you have to protect. And one of the areas of concern I have here is the fact that this data exists in the server. So this is the raw infection points data. This is the most sensitive data that we have, because it hasn't been filtered by the user. And actually, when we say that, even from a privacy point of view, this data can be accessed by multiple players, where in reality, ideally, you want that data to only exist here, or at most being seen by the trace agent. So that's a good example of, and this is where, so one of the things that we talked about was this idea that, this data, for example, that you have here at the top is actually hashed. So when they talk about the hashing, the idea is to prevent somebody from creating a table here with all the data. And one of the conversation we had was, I actually think that you should consider this as a commodity. I actually think that that data should be considered public, because you should assume that whoever wants that data will be able to have. And look, you had already a great case study, right? You're going to have somebody like Simon that decides that he wants to do some low signal detection, and you're going to find that this data is a great way to determine where mergers and acquisitions is happening. And then the idea that somebody like Simon doesn't have the 5 or 10 or 20K required to pay for the, for the computing power to dehash all this data, right, is not going to be the case, right? Because, so my view in this case, we should treat this data as public, basically say the data from a risk point of view should be here, right? And the real effort should be in protecting that guy there. That's what we want. So I want to do a map where you have privacy, where I was going to decide where left is more private or right is more privacy. But if in this case, right is public data and left is private and sensitive data, for me, the biggest problem here is this guy.
Okay, so when we talk about maps and data, we use the term unmodeled, convergent, divergent, convergent, and model. So what we're talking about is that data, it's like in the early days of astronomy, we were collecting not only the movement of the dots of light in the sky, but whether the wind was blowing and whether there were leaves on the trees, because we didn't know what was connected with what. Now, over time, we refined our models of understanding. So that's the process of evolution. So when we talk about privacy in data, what we're really talking about is a user has a need for privacy. And that is linked to things. And for example, that'll be linked to the raw infection pathways. So the raw infection pathways will be linked to their need for privacy. Now, in terms of the anonymized information pathways, it's an interesting question. Well, there's another agent, isn't there? There is a bad actor. And you could always you can put a bad actor on the top. So when we're doing, for example, looking at terrorist attacks, we start from the point of view, what does a terrorist need? They need a payload, and they need a distribution mechanism. And so you map it from the point of view of the terrorist, and you map it from the point of view of defense, and look at the interconnections between them. So I would do the same thing here in terms of, you start with the user, and you've got infected users, non-infected, and you've also got the healthcare, which has tracers. You've also got the bad actors. So the bad actors have needs, and their need is basically, will probably be to gain access to the raw information data, or to decompile the anonymized infection. AI, what was the pathways? Okay, good, right. So I would tend to draw the map from those actors at the top. Does that make sense?
Yeah, and look, and again, not covering a little bit what we're going to talk on the session tonight. Here's, for example, a map that talks about a cyber attack from the point of view of what they can do, right? And how much of a commodity there is. If I want to do a denial of service attack, I have toolkits. I got all sorts of stuff. I got vulnerability exploits. Depends what I want to do. Depends how I want to write it, who I'm hitting to. It depends on the maturity of that process.
Yeah, so if I'm doing a social engineering attack, already many of the components are already commodity, even available on a utility basis. Yeah, exactly. I mean, there are online services that I can just simply send a script to and tell them what sort of voice, what age group, etc. do I want this script read in, and who's the target? I mean, okay, it's all right, fair enough.
So but Adam, does that make sense? That thinking I was kind of going on, the idea that in this case you kind of want to remove as much as we can the RIP data to exist in the system, which is
absolutely,
that bit there.
Yeah, I think that we took that from the previous session as one of the very helpful bits of feedback you gave. We are looking at that. It's something that's not trivial to do straight away, but it's something we're actually looking at. Yes.
So one of the things that Simon and others that we looked at was the idea that we could encrypt this data. Sorry, we could encrypt this data here, which is the user's data. So we could actually encrypt the data, and we can basically only allow the data to be decrypted by the tracer agent in that app. So the only two places where the data in the raw place will exist will be in the user's mobile phone and in the browser used by the tracer. Beyond that, all the data is already so basically this wouldn't exist because you wouldn't actually store data. You would already store it here. And the other thing I would do here is, make sure that the data that you have, that this process, which is the calculate the AIL, is the most important step of all of this. And that's the process that I actually think eventually should be done by a reputable source, because that's the one that is the single. This is also the place of the highest abuse, because this is the one that will have access to, in a way, that data, right? The FIP, and this is the place of highest abuse. So the way I would look at this from a threat point of view, I would actually assume that you have bad actors here. Or actually, sorry, I shouldn't share. Is that window on this thing? Oh, cool. So I would assume that they are bad actors there, right? I would assume that they are bad actors here. And I would assume that the only thing that only in brackets, but the only thing that I will have to protect is this bit here in the middle. And actually what it means in practice is, from a security point of view, you need to basically move all these guys to a cloud level security, right? Because this has to be a commodity. The calculation, the storing, all of that has to be isolated, which is, when you look at, for example, why some of the cloud environments is more secure than others, is because they commoditize large chunks of the security practices that you need to do to protect data at rest, right? And I would say, and by the way, like if you look at the AWS game plan, right, they will eventually get here, right? Eventually you will have somebody who provides a safe healthcare storage and provides a safe healthcare anonymization practices, which is kind of where you're going with this.
Good. Yeah. I'm glad you mentioned tracers as possible bad actors as well. Good.
Yeah, because, from a security point of view, right, and the irony is that, and this is what frustrates me with the current social networks, because you can detect this here, this is the easiest place, if you're paying attention and you're modeling, to detect bad actors, because the attackers don't know what good data looks like. And the name of the game is not for the attackers to submit data, as much as they can and abuse as much as they can, and you have to defend against everything. Is you want the attackers to make one mistake. And one mistake is sending data that doesn't make sense. It's very hard to send, for example, a user data in a way that makes sense across your entire user fleet. It's very easy to send user data that looks like a human. It's very hard to send it in a way that looks like a human that uses your app, right? And if you're looking at this data here, this is where all the machine learning, this is where all the visualization and all the effort should go, and it becomes a gamification game, literally. It becomes of making it super expensive for the attackers to literally replicate normal users, to the point where they might actually have to, and remember that, there might be, value in paying somebody to pretend to be malicious, right? Not being funny, but like, there's going to be a huge amount of things in the world that will depend on who can do what, and this kind of data. So we're putting a massive asset.
So I totally agree, but one of the things you do is the scenario play. So, for example, in this case, you take on the role of the bad actor. So the easiest way of attacking the system and making money that I can immediately see is the one you just mentioned, in the fact that basically we know, is if you've got an infection path which goes to a rival or somebody's shop, okay, then that basically potentially will cause harm to the brand of that shop. So what do? You basically have a couple of tracers in your pocket. You basically have a couple of people create some fake pathways. You get the tracers who you're paying anyway to start submitting or accepting or giving the 6-figure code, whatever it is, so that the bad data is put into the system. And so now you've got a way of basically going around to shops and saying, look, if you don't want to end up on the COVID list or whatever,
Exactly.
you pay us some money. Okay. There becomes all sorts of mechanisms. So that sort of thing you have to play against.
Yep.
Great fun.
And this actually takes me, sorry, Adam, any comments on this?
I think Adam had to drop. But I'm there. Yeah, I mean, only to say that it's easier than that because the tracer has the ability to put in arbitrary points themselves. The reason we put that in is actually we want to support both users who don't have smartphones at all and maybe telling their reporting their paths from memory. We also want to support users who may have a smartphone but didn't think to install the app before they went and got COVID. And so for both of those reasons, we want to allow contact tracers to basically do the sort of normal contact tracing interview they would do today, but still feed the position data into this system that can be, so that other app users can benefit from. Mm-hmm. But that unfortunately does create wide open the opportunity for them to just point and click and put places in, put points in their whatever places they may want to target for whatever reason. This also then ties to the stuff at the top end, and this question, Dinis, we've had before about, should the points of concern data be public in plain text, or should it be obfuscated in some way?
They already are. Once I get that set of data, I'll prove it to you. They are, mm-hmm. They are, hash data the way you have here is as clear text. Okay, it's one step away from clear text, mm-hmm. and there's enough commercial interest to do that, and it scales at cloud speed. So you kind of, need to just about consider that as clear text.
Okay. So So that is an important question for us. How do we identify and weed out corrupt contact tracers using the system?
Yeah. So this is where the privacy gets interesting, because I would argue that your point should be to preserve the privacy of the user, not of the tracers. So for the tracers, you should absolutely log who they are, what they're doing, what data they submitted, etc. So you think from a blast radius, it means that, again, once a tracer makes a mistake, look, to the thing, you would never be able to prevent a malicious tracer, right? By proxy, they're going to be humans. They can do stuff. In fact, you find that they might even do mistakes, which actually you might catch with the same process. But what you want is as soon as they make a mistake, or as soon as they weaponize their malicious intent, you catch them, but you destroy the whole network. I.e., you destroy all the set of data, and you're basically able to redact that data. So you make it expensive, right, to hire those tracers. So from a criminal point of view, it doesn't scale if every tracer I use, every malicious tracer that I be able to corrupt, it gets destroyed with one use or two uses, right? Mm-hmm. Because it's expensive. So if you look at the commercialization, you need to think of the business model and the return of investment of the entity that wants to have those tracers in their pocket, right? So there's an effort to convince them. There's an effort to put them in place, right? Even if it's compromised computers. Remember that one path of this is to actually compromise the tracer's computer.
Mm-hmm. Yep.
Right. Agreed. So that device, that laptop, which you don't control, could be compromised. So one topic I wanted to cover before we leave. So the thing I wanted to then do was to, which I think we can continue, is to do multiple versions of this map where you look at, so let me just clear the thing, where you look at the risks on this, look at the ability to handle instant response. So this is a really great way to look at your security, where you start to ask, when you have an incident, not if, right? Is when you have an incident, what's your maturity of the multiple components? How much visibility do you got? How much can you track it? How much can you shut things down? What's your playbooks? And you'll be amazed sometimes that you might be putting a lot of your security in areas that actually won't make a big difference. And you might have massive single points of failure in this system when you have an incident, right? The other one, which I found very interesting, is the time to fix. which is you should measure how long it takes you to push some fixes to the system. Because if you have parts of your system that are really hard to fix, the risk of those systems become way, way higher. And sometimes it's easier for us to put security in areas that we feel we can fix very quickly, but actually when you add the time to fix and the damage that can be done in that period, the actual risk is low, where when you have entities here that have really high time to fix, then the risk becomes massive. So this is an area there, and there's some cool maps that actually Tony created where, and I think Simon has a couple, where you can add more metadata to the maps. So you can add different types of circles, different colors, different things. So you can almost do different types of readings on the map, especially when you start to apply the kind of climatic patterns, which is the other thing we eventually should cover. But and the privacy view. But the thing that I feel it would be really cool and very powerful, and actually I think could be something to prevent the path that Simon very kind of effectively was kind of nudging, which is how do you make sure that these apps in the future still remain the privacy settings that you want and are not, corrupted. And I saw recently this thing, I don't know, have you seen this? Security and privacy label. Mm-hmm. This is really cool, right? And this is actually, this is going around and round. It's a good example of it's maturing, it's getting more and more productized. This just happens to be one of them that I saw recently, but it's really cool. So the idea is to create a label for IoT in this case. And what I would like us to do in a session on Thursday is to think of what should the label look like for COVID apps. So what's cool about this, and there's another example here, this is something created by actually, I think Jeff Williams 15 years ago, something like that, when we actually have this idea of having software facts, right? Where you actually say, how many vulnerabilities you've got, SQL injections, how are you in authentication and stuff like that, but it's very important, right? Because you start to capture this. So the idea here is to capture the security properties. And I think you guys can play this game really well because you're already going to come out of this, looking really good, because I would say first key questions is commitment to privacy. Where's the data? Is it centralized, not decentralized? In fact, do you have attrition to extract data? Do you require user consent? So you can see that, you're going to get lots of green, right, on this path, where I think there's lots of apps that don't. But the idea is to address those privacy concerns head on and then find a pragmatic way to measure the key properties of each system. Mm-hmm. And in a way, if you think about it, this is the productization is evolving the maturity of what it means to have a privacy conscious application. Because I'm sure that tons of apps out there claim to be privacy aware, but you kind of have to, first of all, make sure they're talking the talk, and then are they actually delivering it correctly? Do they have, threat models? Do they, like, for example, you guys do an amazing thing where you're saying we're going to try to, or you're using the OWASP ASPS, and we're going to do, pen testing, you're going to do security reviews, you're going to do all other OWASP projects, etc. Right? That is very powerful. And then it's about when you execute it. And I think it's very important to create a positive model that you get rewarded for doing all those things.
Yeah, it's interesting. There's a bunch of things that are in this sort of space in terms of people setting ethical standards or privacy standards for apps in this space. A lot of them take the view of a sort of a set of principles that everyone will sign up to, rather than measurement against a series of metrics. Yeah, I don't think I've seen anything exactly in this form.
Yeah, but in security, intent is not enough. Mm-hmm. In security, you actually have to prove it. And I think in your case, I think it's super critical because you are positioning yourselves as you're building a reference implementation, which is fine because it allows you to scale. But it's very important that your amazing work doesn't get completely sort of shot down in flames because somebody implements the app in a very insecure way, which is always going to be the case. That is possible because you are open source.
Mm-hmm. Yep.
So I actually think that even when you say about certifying, for example, your healthcare providers, you should be providing one of these for those healthcare providers, but also for the implementations of the work.
Oh, I like that. That's the so anybody can do this as a community model. but what you're going to do is have a trademarked image, which basically, if you comply with these your criteria, then you get you're a certified provider of whatever it happens to be. So you certify the healthcare providers, etc. And what you're aiming at there is if people start trying to manipulate this space and make it and take away some of the privacy, so we go down the centralization path and capturing all sets of data, you're saying, well, they no longer get the fair trade mark on
exactly.
it. Yeah,
Exactly.
very nice.
But you have to go down to text.
Yeah, you do.
But look, if you look at but if you look at the path these guys are going, right? So look at this, right? So if you look at something like this, which is, let me just quickly open it up, which is the application security vulnerability standard by OWASP, right? And I'm just going to open up their actual pages, but I can find it through here. So where is that link from your? Actually, I'm just trying to find the link that you guys created. Sorry. So they're already kind of going down that path where they've already sort of, for example, committed to do a number of checks. So here we go. Cool. Back in. There you go. Got it. Okay, I'm sharing my screen. Share screen. Which one is it? Yeah. All right. So can you guys see this? So this is, this was the first time they kind of got me here, right? Because once I saw this, I was like, these guys are amazing, right? They actually have a page that talks about the design principles, right? It's like security conscious, this is already better than most organizations I've seen, right? But one of the things they have here, which is great, for example, is these principles, right? So security implementation, and these are sort of kind of the principles from this application security verification standard OWASP has published. So basically, these are test cases, right? So the logic is that these are the things that you need to be doing in order to be secure. And security is complicated, right? You can't shortcode this stuff, right? Either you have a threat model or you don't, right? Either you have data considered sensitive in the context of a mobile app is clearly identified. You'll be amazed how many apps that doesn't happen easily, right? Or you don't get that. So this is the foundation. In a way, it's a graph, right? And eventually a map, right? Because actually, I think applying, and this is where I think maps are interesting because, this becomes a gigantic graph because you have all the dependencies. But then when you look at what you actually can do with the labels, I actually think that the map will give you a level of granularity and a level of flexibility that you don't get here. It's because like trust fundamentally is just it's a lever, right? It's like so, the things.
Yeah. Can I ask? Can you just throw up the map again? And I'm sorry, I know my handwriting is dreadful, so I'm going to try to draw neatly and just summarize just a few bits for me. Okay, so I want to annotate. Good. Right, so the first thing is you've got users here. Let me see if I can. You've got users, but you've also got those users included the COVID infected users, because ultimately they're using exactly the same application. The difference being is in this case, where they are infected, they're also doing the transmission. Okay, let's try and, perfect. Okay, transmission. I'm sorry, my handwriting is still terrible, but that also requires authentication, which was the 6 codes, and that requires, this is where your tracers are at the top, but you've got bad actors attacking. You've also got another actor in this, is the open source group itself. And so what you've got with this open source group, or whatever you've called it, is a requirement to provide trust for this space. So this is where you're talking about the use of certification.
Yep.
There's nothing special about certification or trademarked images. To basically say that you've implemented this in the correct way. See my handwriting. I'm like a terrible handwriting, but there we are. Certs. There we are. So the other thing is, so a lot of this stuff down here should be connected up here. One of the things you want to do is you want to remove that whole store RIP. That's just an unnecessary risk. The other thing you want to do was where it is the tracer doing the boundaries, you wanted to shift the responsibility from that to the actual users themselves. Is that correct?
Yeah.
Okay.
Well, I'd see that one as a responsibility we want to share, because we hope that with training that contact tracers will have a better understanding about privacy risks than individual users. Though it may be that we can encode that in some sort of workflow to guide through the users through a best practice of redaction. Not sure, but at the moment that's the idea of moving that to users is very very early stages.
Okay, so you've got, there's several bits there. It's the moving of responsibility, ability to users. You've got the bad actors issue, so you're going to have to do some way of making it, whether it's some sort of auditing process or whatever, just make it so it's just not economical to exploit through that way. You've got the removing of the RIP. The other thing that you've got is making sure that as many of these components are commodity-like as possible. And also the introduction of certs. So if I go through this, 1 certs, 2 bad actors, 3 moving responsibility, 4 commoditizing, and 5 realizing it, you're making sure it's clear it is the same application. You're not going to end up with 2 different applications. It's a single application. Is that correct?
Yeah, I'm not sure what you've put in as 5 there as a sort of to do.
Oh, it's not a to-do. It's just it's a clarification, because the way that it is drawn at the moment seems to imply that
for the diagram, understand? Yes.
Yeah, it seems to imply that there are 2 different applications, but in fact, this and this are. I know they're named the same, but they're identical. They are the same thing.
Sure.
Okay. Good. All right. Interesting. Thank you. I just needed that to clarify, even with my messy, and I'm sorry, apologies, my handwriting is so awful. Yeah. But that just helps me understand what you're trying to do in the space a bit more. Thank you.
Yeah, brilliant.
Did anyone happen to notice the questions in chat?
Yeah. Oh, sorry. Let's take a look at it.
I haven't looked.
So John, when you say example how to map a thread like a terrorist or hacker, that's the kind of stuff that we're going to do at the session tonight. At the session, I think at 8 o'clock, where we're looking at mapping threat mapping.
Oh dear, oh dear. I'm not sure I want to be involved in that. The use of maps to cause damage. There we are.
No, so this is to understand what they can do.
Yeah, I know.
Not to plan it.
I do like the other way, though. That sounds fun.
If you want ideas, read Bruce Schneier. I think for a while he did movie plot theater kind of examples where he asked the community to come up with all sorts of crazy ways to raise cyber hacks, and it's. It just shows you how, there's not a lot of creativity out there on the way to actually cause lots of problems. So Simon, is it worth you showing quickly the kind of stuff you had prepared?
No, I can save it for another day.
Okay. Because
we've got 8 minutes left.
Okay.
It's perfectly fine. I will use it another day. I either later today or sometime tomorrow.
Fair enough.
So can I ask, have you found the maps helpful here at all, or have you found them confusing? So
I think there's seems to be a lot of different things sort of going on, I guess. So I can sort of see there's the sort of plotting stuff in terms of users that I think, and users and needs, which I think is one helpful way of looking at things and bringing out things. And there's this the kind of commodification axis where your kind of sort of general steer seems to be for kind of obvious reasons, but also I think crucially for security reasons, to shift stuff right as far as possible. And then the discussions led to, I guess, identification of a few other things. What else should these maps be helping me to see?
Oh gosh. So maps are used for a whole range of things, for anticipation of change in the landscape, or how you organize and structure yourself, to how you manipulate a space to your favor. I mean, they're used in all sorts of different areas. I mean, to begin with, the single most important thing is getting an understanding of the landscape, which is a process of mapping it out and allowing others to challenge and question you. So, have we got all the users on here? So we've got the COVID users, there's the healthcare connected to the tracers. You may want to map out bad actors on this space as well. Do we know the needs of those particular users? Are the components, are we treating them in the right way? Those are all the basic sorts of questions which maps help with. And over time, as you get more used to the process, you use them for structuring contracts, to organizing yourself.
We did have one more. Sorry.
Yeah. Sorry.
We did have one more question here in the chat. It says, while mobile devices are ubiquitous, accurate and context-aware location tracking like GPS and Bluetooth is generally not. Is this a risk that should have been on this map? So it sounds like they're saying being able to accurately track the location of the person is not something that that we can do everywhere, even though people have mobile devices. So is this kind of risk something that should have been on this map?
Yeah, we should. So we should be checking that, right? So we talk a little about it on the session, because GPS has a number of limitations, right? So you should be taking that into account.
Yeah, I mean, in terms of whether it should be on the map or not, I'd let other people talk to you. But in terms of that not being a commoditized thing in terms of the application development, absolutely. The GPS loggers, accurate GPS loggers, are definitely in the product category. There's a number of things you can get off the App Store that that do that. The difficulty is doing that in a battery efficient way on a long-term basis. So most GPS loggers will be battery intensive and run for, they'll use it for, an hour or so while you go on your run or your walk or whatever it is that you want to plot location of. Something that's actually doing it, firing up the GPS every 5 minutes and getting an accurate location is actually is this kind of slightly new thing that we've had quite a lot of challenges doing and haven't found a lot of kind of existing implementations out there. So it's definitely agree with that being a novel application of that particular technology.
A novel practice. So in the case of Bluetooth, there's nothing special about Bluetooth, but this is you're saying this practice of using it for this location is novel.
Well, it's required Apple and Google to re-implement a whole bunch of stuff in their operating systems. I think absolutely is. It's novel for proximity detection in that way.
Can I ask, Denise, was that you who put server in custom built? Are you kidding?
It was. No. So Dermot, one of the questions you asked was, for example, one of the use of this map. If you're not using Google Cloud, right, and if your map looked like this, where the server was here instead of here, we would ask that question on reverse. So we would say,
"Are you kidding?
Are you kidding?" Right. So the power of a map, when you look at these components, is basically, and it allows to challenge the assumption and say, are you using the commoditized services that already exist out there?
Mm-hmm.
Right. And so GPS is actually an interesting example. So for example, it would be tempting for somebody to say, hey, GPS is a commodity, but you guys might turn around and say, actually, it's not. GPS, given the current implementation, is probably a lot more over here, right, on this side. So the power of a maps allows you, so you could say GPS is here, or in some users, it might be even more immature because maybe their phones don't have it, or like you said, they only turn it on for a little bit. So it's a very novel practice to do that.
Mm-hmm.
But then when Google and Apple push the thing, they pushing this outside. And this is something that, you know, one of the things that Simon talks a lot is about, sometimes you have to wait for the future to arrive, right? So if you know that Apple and Google are going to push GPS quality to the right because they're commoditizing that, then you probably don't want to invest on it. Just deal with the fact that you have a margin of error today, knowing that in 3 to 6 months from now, that's going to be better.
Mm-hmm.
So Greg Mann asked in the chat, is there anything from the offender tagging industry that could help with the logging? Sounds like you're referring to the sex offender tagging industry, perhaps, or I'm not sure actually what.
So prisoner tracking, basically.
Prisoner tracking.
So things like ankle bracelets and everything else. So it's a similar sort of problem in terms of prisoners where they, well, it's actually, most prisoner tracking is the geofencing side. Is that what you meant? Or because I'm not sure in the UK, do we do tracking beyond geofencing?
But I guess the question is, should we learn from them, or is that something useful? I guess, you know, they have experience a little bit with tracking these things, right? Although I'm sure that the privacy requirement on there is not very high on them, right? I guess they don't take the privacy of the offenders into consideration at all.
Yeah, I mean, there's GPS tracking devices that do a great job on battery life and so on, but they tend to be of a model where you the sort of GPS type luggage tags and things that have been developed in recent years. The idea there is that you read them pretty infrequently as to where they are. So they can go with a pretty long battery life and be out for a month or so. And then when you actually want to check where it is, and I actually haven't looked much at how it works, but again, it's slightly different from being able to take a continuous read. It's just one of these things where there's a bunch of different considerations to balance, and if you want a particular combination of them that hasn't been developed before, it's hard. We've been looking around. I don't think we've. What we've had to do is not. It's not been kind of ridiculous advances here, but it does. We haven't found anything that we could leverage that existed already. Although obviously, we've had GPS location libraries, etc., that are commoditized. It's just a question of exactly how you utilize them. That's been a bit novel.
Cool. Well, actually, so damn it. Any final comments? Since we just bang on the hour, I hope this was a bit useful.
Yeah, it is useful. Lots to think through. Probably could draw some pictures, I think. Based on that. Yeah, very useful. Thank you.
Cool. Simon, any final comments?
Thank you for inviting me along. I learned something completely new about COVID tracing apps. So I'm going to go have a look now.
Oh, and thank you. From my point of view, it's not every day that you do a map and you get, Simon to actually, work on top of the map you created, right?
Sorry, I've also learned that despite my very expensive artist tablet and pen, that I can barely write. Hopefully I will improve over time.
So the problem wasn't the technology, right?
Oh no, the problem is definitely me. My hand, anyway, awful.
Oh, I have the same problem. It's the bit between the computer and the chair, right? It's the bit holding the pen that is the problem. I completely share with you. All right, brilliant. I'm going to stop recording now. Thank you very, very much for this. Actually, let me just do that quick recap. So on this session, we looked at the COVID Safe Paths app and Safe Places app. And we had a really good conversation about how it works. We went from a diagram, a graph, a threat model, all the way to maps. And I think it's a very interesting example of actually how to do mapping, and the conversations and the questions and the dialogue that it promotes. I think it's a great example of that in action.